Okay, welcome to yet another application video, and the one for the moment is called to raise or not to raise. And this example comes from one of those fulfillment centers, and a fulfillment center is one of those places where workers go around and collect items off the shelf, pack it, and send it. You can think Amazon, you can think any of those companies that fill online orders and ship them off. Okay, so this is an online ordering fulfillment center, and a shift average turns out from everybody in the company. The shift average we know because, of course, we keep data of what gets shipped out and how many people are working and all the rest of the stuff. And so we know the true shift average. The true shift average is the true mean, and the true mean here is 25 packages per shift. Has to do with the type of stuff they ship. Okay, now one of your workers comes in and says, hey, I deserve a raise because I'm doing better than anybody else I know on the shift, and I'm doing great and I deserve a raise. And you go, maybe you do, maybe you don't. Let's find out. And in order to find out, the first thing you do is you go collect some data. So X here is the number of packages in a shift from this particular worker. And you go out and you collect some data from the last several shifts. And I collected some random ones here, and it came out like this: 24, 21, 22, 30, 35. Well, okay, it's got some really good days here, some that aren't quite so much. Still, is it going to be better than that 25 shift average? Does the guy deserve a raise? Well, let's do some working on that. Because what we're going to do is we are going to test whether this guy deserves a raise. And to do that, we are going to do hypothesis testing. Now, the first hypothesis is, does this guy's average end up larger than the 25? So my null hypothesis is that is the truth for this guy, is the true mean for this guy, I'm going to write this as mean, is the true mean here the same as the shift? Now, notice I wrote that as equal, even though I've been saying words like more than, because when you do what's called one-sided hypothesis testing, meaning I only care if this guy actually packages and sells more than the average, because that's the only way I'm going to give him a raise. If he sells significantly average or packages significantly less than 25, he's not getting a raise. So I only care about one side of the distribution. So this is a one-sided hypothesis test. So it's a one-sided hypothesis test. Well, okay, so I'm only sounding like I need one, but the way I write my null hypothesis is that it is a single point. And the single point is what the mean was. It's the alternative hypothesis is where the magic happens. The alternative hypothesis is more than 25. So it's this alternative hypothesis that really tells you it's one-sided. I keep this one single point for the hypothesis test. Okay, so that's my hypothesis test. Again, this thing is going to be business, so I'm going to use my significance of 5%, which means I need a confidence level of 95%. Okay, fine. Notice I don't know what standard deviation is. It's not a population standard deviation. I have to calculate it. So I collected this data, and so the first thing I do is I find the average from this data. Well, the average from this data turns out to be 26.4. So gosh, so far, looking good. Looks like he's getting a raise. That looks more than 25. But is it enough more than 25 that he deserves the raise? To do that, we need to look at the standard deviation. Again, you know how to calculate a standard deviation. You can do it on your calculator, you can do it by hand, I don't care. But it turns out that the standard deviation here ends up being, there it is, 5.94. All right. Pretty large standard deviation, but then notice I have a day as low as 21 and another day as high as 35. So yeah, it's kind of spread out. So I have that information. All right, notice I have an estimated or sample standard deviation. That means I need to go on the student's T table. Yeah, I know, student's T. The guy's last name was Student. That doesn't mean it's just for people who are in education. It means the guy's last name was Student. Okay, so student's T, I need my degrees of freedom, which are going to be n, number of observations, minus the number of extra things calculated from the data. Well, I have to calculate the mean, so what's extra? Extra is the standard deviation, so it's n minus 1. Or, in this case, 1, 2, 3, 4, 5 is n. My degrees of freedom are 5 minus 1 are 4. So I go on the student's T, degrees of freedom of n minus 1. I'm still not quite done. And the reason I'm not quite done is because this is a one-sided test. If I want 95% in the acceptance region, but I only care about the top side of the distribution, I don't have a negative down here to reject the null hypothesis. So that means all of my significance has to go here, or 5%. So when you're looking up the critical value in your student's T table, you're looking for a one-sided hypothesis test in the table, or 5% significance, which means at 4 degrees of freedom, I need a critical value of 2.132. Notice that's not 1.96, 2.132. Look it up in the table. All right, so far, so good. All right, so now what I want to do is I want to get to my test statistic. My test statistic is again going to be sample minus null over the sample standard deviation over the square root of n. Or in this case, I've got the 26.4 minus 25. Remember, this is my null right here. Over my sample standard deviation, 5.94, over the square root of n, n's 4. I get a test statistic of 0.52. Well, 0.52 falls in the acceptance region. So I am going to accept the null. What does that mean? Well, what it means is that this person who came forward, who, was getting some days like this, didn't have enough higher days to offset the lower days in the sample to show that they were for sure greater than 25. Yes, their average was slightly better than 25, but it wasn't far enough above 25. So I am going to accept the null, and that means no raise. Well, in today's job market, you just don't want to say, get out of my office, no raise. You're not going to do that. So instead you say, look, tell you what, why don't you go work, be great, be wonderful, you're on the right path, go work a little harder and go out there and keep working, and tell you what, in 2 more months, come back, and if you have improved, I'll give you that raise. And so the little person leaves your office and they're happy thinking they've got a chance at the raise, but you haven't given them any money yet. You just send them off. Okay, so I'm going to send you off while I clean the board and pick up the data for 2 months from now. So we will be right back. Okay, a few months later, that employee comes back. And what you do is, again, you go out and you collect some data. Now, I've just summarized it here. This was when they came to you originally, and you had an average of 26.4 out of 5 observations, standard deviation of 2.54. Now, you go out, take 5 more observations, and you find an average of 33.65. But a rather large standard deviation. In other words, some days they did really, really good, some days not so much. Okay, so I want to test if they're doing better. I no longer want to test if they're doing better than the 25, because I promised this person, as long as they improved, they'd get a raise. So I am going to do a 2-sample normal standard deviation estimated, because I estimated it out of the data, hypothesis test. Now that kind of hypothesis test says that the true mean from group 1 minus the true mean from group 2, does it equal 0 or does it not? Now, I don't have to say just better, because since I'm looking at two groups, either one is better or the other is, so I can do it this way. All right, so this is what I want to do. Now, first of all, we need to find some things. Notice I've got estimated standard deviation, so again, I am going to need the student t critical value. To find that, I need my degrees of freedom. My degrees of freedom are the total number of observations minus the extra things calculated out of the data. So how many extra things are there? Well, I had to calculate the x bars because those are what I'm comparing. The extra things are the standard deviations, so I subtract off 2. Okay, so I've got 5 plus 5 minus 2, or 8. So my critical value, again, at 95%, is going to be, as it turns out, 2.306. What I've got here, again, if I've got 95%, I've got 2.306 minus 2.306. If I get a test statistic that lands in the middle, it means that I'm going to accept the null hypothesis that they are the same, no raise. If, however, I reject the null hypothesis, in other words, I land in one or the other, if I reject, I'll have to go back and see if now is higher than earlier, in which case you get the raise. All right, so let's calculate ourselves a test statistic. Now, my test statistic here is going to be the two samples, x bar from group 1 minus x bar from group 2, over a rather ugly standard error. It's going to be the square root of 1 over n1 plus 1 over n2 times the square root of n minus 1 times the standard deviation of group 1 squared plus n2 minus 1 times the standard deviation of group 2 squared over n1 plus n2 minus 2. I'll leave that math to you, and it becomes 2.499. Well, 2.499 gets this. So I am in the rejection region. So I'm going to reject the null hypothesis. So what I can say is they are not the same. Okay, they're not the same. But do they get a raise? To determine that, I will need to know that the average from the current data set is larger than the average from the previous data set, because I picked group 1 being the larger average. So now is group 1, then is group 2. All right, so I have rejected. I got a positive test statistic of 2.49. So x1 minus x2, or group 1 minus group 2, is a positive number, which means 1 is bigger than 2. So this number is indeed bigger than this number. Be careful, what you are comparing right now is only after you've rejected the null hypothesis. You go back to the sample means, not the standard deviations, the sample means, and say, oh, yeah, they're fulfilling more now. In other words, let's give this person a raise. And that is how you do two-sample, standard deviation estimated hypothesis testing. Thank you for your attention.